Welcome to Future Human Science, where we explore the most fascinating and mind-bending concepts in technology and science. Today, we're delving into a topic that has captivated imaginations for generations: the physics of time travel. From the pages of science fiction to the frontiers of theoretical physics, time travel remains one of the most intriguing and controversial subjects. But is it really possible? Let's journey through the science and theories that explore whether we might one day travel through time. Time travel is a concept that has fascinated humanity for centuries. It's a popular theme in literature and film, from H.G. Wells' classic novel, The Time Machine, to the Back to the Future movies. But beyond the realm of fiction, is there any scientific basis for time travel? To answer this question, we need to dive into some of the most profound principles of modern physics. First, let's start with the basics. What is time travel? In its simplest form, time travel refers to moving backward or forward through time, much like we move through space. Imagine being able to visit the distant past or leap into the future. While this might seem like pure fantasy, some theoretical models suggest that time travel could be more than just a flight of imagination. To explore the scientific feasibility of time travel, we need to look at the foundations of modern physics, particularly the theories of relativity developed by Albert Einstein. Einstein's theories revolutionized our understanding of space and time, and they are crucial for any discussion of time travel. Einstein's special theory of relativity, introduced in 1905, fundamentally changed our understanding of time. According to this theory, time is not a constant, unchanging entity. Instead, it is relative and can vary depending on how fast you are moving. This leads to the concept of time dilation, where time can pass at different rates for different observers. For instance, if you were traveling at near the speed of light, time would slow down significantly for you compared to someone who is stationary. This effect, while incredibly small at everyday speeds, becomes pronounced at speeds approaching the speed of light. Special relativity also introduces the idea that the faster you travel, the more your perception of time changes. This means that if you could travel at such speeds, you could, in a sense, move forward in time relative to someone who remains stationary. However, this doesn't mean you can travel backward in time or visit distant past events. This is where general relativity comes into play. General relativity, introduced by Einstein in 1915, expands upon special relativity by incorporating gravity into the picture. This theory describes gravity not as a force but as a curvature in space-time caused by massive objects. According to general relativity, massive objects like stars and planets can warp the fabric of space-time, and this curvature can influence the passage of time. This leads to the concept of gravitational time dilation, where time runs slower in stronger gravitational fields. One of the most intriguing predictions of general relativity is the concept of wormholes. A wormhole is a theoretical passage through space-time that could create shortcuts between two distant points. If a wormhole could be stabilized and traversed, it might allow for faster-than-light travel between 2 points in space, and potentially 2 points in time. While wormholes are a fascinating theoretical possibility, they remain speculative and face significant challenges. For instance, they would require exotic matter with negative energy density to keep them open, which we currently do not have. Another potential avenue for time travel is through the concept of closed time-like curves, CTCs. A CTC is a path through space-time that loops back on itself, allowing for the possibility of traveling back to an earlier point in time. This idea arises from solutions to the equations of general relativity, such as the rotating black hole known as a Kerr black hole. In theory, CTCs could allow for time loops, but their existence and stability remain highly speculative and controversial. However, the concept of time travel is not without its paradoxes and challenges. One of the most famous is the grandfather paradox, which arises when a time traveler goes back in time and alters events in such a way that their own existence is threatened. For example, if you traveled back and prevented your grandfather from meeting your grandmother, you would never be born, raising the question of how you could have traveled back in time in the first place. Such paradoxes highlight the complexities and potential contradictions inherent in time travel theories. Another challenge is the enormous energy requirements and practical limitations. Theoretical models that suggest time travel often involve massive amounts of energy or exotic materials that are currently beyond our technological capabilities. For example, stabilizing a wormhole or creating a closed time-like curve would require energy on a scale that is far beyond what we can currently harness. Despite these challenges, the study of time travel continues to inspire scientific inquiry and theoretical exploration. Physicists and cosmologists are actively researching the implications of relativity, quantum mechanics, and advanced theoretical models to better understand the nature of time and the possibilities of time travel. Some researchers even explore connections between time travel and quantum mechanics, such as the idea of quantum entanglement, where particles become interconnected in ways that defy classical concepts of space and time. In conclusion, while time travel remains an exhilarating concept and a popular subject of scientific speculation, we are far from achieving practical time travel. The theories of relativity provide intriguing possibilities, but significant theoretical and practical obstacles remain. As our understanding of physics and technology advances, we may uncover new insights that bring us closer to answering the question of whether time travel is truly possible. Thank you for joining us on this exploration of the physics of time travel. If you enjoyed this journey through one of science's most captivating topics, don't forget to like, subscribe, and hit the bell icon so you never miss an update from future human science. Until next time, keep your curiosity alive and continue exploring the mysteries of the universe with us.